The HFE35C is an easy-to-operate, far-field broadband RF meter designed to measure radio frequency and microwave radiation from 27 MHz to 3.3 GHz with the UBB27 ultra-broadband omnidirectional antenna and 700 MHz to 2.7 GHz with the log periodic directional antenna. The values displayed are the sum of all sources within the frequency range of the meter. This frequency range covers the radiation emitted by cordless phones, decked phones, cell phones, baby monitors, Bluetooth devices, Wi-Fi, smart meters, cell phone towers, radio and television broadcast towers, and more. The meter displays the RF power density measurement in microwatts per square meter. Included with the K5 carrying case is the meter with a 9-volt battery installed, the operating manuals, a UBB27 ultra-broadband omnidirectional antenna, a log periodic directional antenna, warranty, and certificate of factory calibration. The HFE35C offers excellent sensitivity down to 0.1 microwatts per square meter and up to 1,999 microwatts per square meter with the log periodic antenna in 2 ranges. When measuring with the UBB27 antenna, the minimum displayed value is 3 to 4 microwatts per square meter due to technical limitations, but still maintains a 0.1 microwatt per square meter resolution. The HFE35C has the ability to measure in RMS, a time average signal value, and peak value that shows the highest output of the signal. The meter's adjustable audio tone replicates the signal patterns and intensity of measured RF emissions, which aids in source identification and direction. Also included is an auto power off function after 40 minutes to conserve battery life. To attach either antenna, insert it into the slots on the top of the meter as shown. Feed the antenna cable underneath the meter and connect it to the antenna socket. The connection should be snug, but be careful not to over-tighten. When the UBB27 antenna is properly attached, you will see a red and green light as shown. The red light means the antenna is properly connected, and the green light means the internal circuitry of the antenna itself is working correctly. The log periodic directional antenna measures in the direction that you are aiming. If you could see its detection pattern, it would look like this. With this directional pickup pattern, this antenna's best use is to identify the direction of a radiation source. After this source is known, further measurements are done with the omnidirectional UBB27 antenna, which measures radiation from all directions simultaneously. If you could see its detection pattern, it would look like this. If you do not know the source direction of radiation, begin measuring with the log periodic antenna. Set the signal switch to peak mode and set the signal range to 199 microwatts per square meter and power the unit on. Always use the peak signal measurement mode when comparing your results to building biology guidelines. This switch is on the left side of the meter as shown. Slowly scan an area and follow the direction of the highest field strength. Adjust the volume level of the sound as needed. If the display is showing only a 1 at any point, then switch the range to 1,999 microwatts per square meter and continue scanning. Once you know the source and direction of concern, continue measuring in the affected areas with the UBB27 ultra-broadband antenna. Before changing antennas, power the unit off. The purpose of the UBB27 antenna is to measure total RF exposure from all directions at once. This simulates what your body experiences with exposure from all sides across a large frequency range. In addition to covering a wide frequency range of 27 MHz to 3.3 GHz, the other advantage of measuring with the UBB27 antenna is that it's better equipped to detect hot spots caused by complex reflections. These localized areas of high radiation are common inside buildings. To measure with the UBB27, confirm that you are still in peak signal mode, set the signal range to 199.9 microwatts per square meter, and power the unit on. be sure both the red and green lights are illuminated on the antenna. Slowly scan an area by rotating the meter 90 degrees and back, and slowly move it around the area for at least 15 seconds to find the highest reading possible. While measuring, try to keep the antenna as far away as possible from you to reduce the field distortions from your body. This means that if you're standing with the meter in front of you, your body could be blocking some of the radiation that's coming from behind you. Adjust the volume level of the sound as needed. If the display is showing only a 1 at any point, then switch the range to 1,999 microwatts per square meter and continue scanning. If the display is still showing only a 1 when measuring on the 1,999 scale, you can increase the measurement scale by 100 times with the addition of the available DG20 G10 attenuator. To connect the DG20 G10 attenuator, power off the meter, disconnect the antenna, then attach the attenuator to the meter. And finally, connect the antenna to the attenuator as shown. When the attenuator is properly connected, it will show a green light as shown. With the attenuator attached, the readings on the meter are to be multiplied by 100. For example, if the meter is showing 225, measuring on the 1,999 microwatt scale, imagine 2 extra zeros, so the actual value with the DG20 G10 attached would be 22,500 microwatts per square meter. Once you have determined this highest reading, compare it to the latest building biology guidelines. Currently, SBM 2008 is the most recent building biology standard. A reasonable goal after mitigation would be to have levels reduced to the slight concern level in microwatts per square meter as shown. For more detailed information about the HFE35C and examples of common sound sources of microwave radiation, please visit the Safe Living Technologies website at slt.co.